In this video, I'll be teaching you about Newton's method. Now, Newton's method is basically approximating the real zero of f of x. This is essentially finding the x-intercepts in the graph. This is normally used in your calculator, and this is the formula that it goes through to figure out these zeros. Now, before doing Newton's method, you must check three key properties. F of x is continuous on the interval a to b, f of x is differentiable on the interval a to b, f of a and f of b must have a sign change. So the line on the given interval cannot have any discontinuities. The line may be continuous, but in some cases it may be indifferentiable, so there cannot be any cusps or vertical asymptotes. Finally, f of a and f of b, meaning the y values of f of the a and the b, must have different sign changes. Now, Newton's method is used a lot in engineering problems, such as finding the area ratio for rocket nozzles. If these three properties are met, then there must be at least one zero, or c, on the interval a to b. And this is shown in the intermediate value theorem, where if a line is continuous on an interval and there's a sign change, then there must be an x-intercept. So this is the formula for Newton's method. Now, a lot of it looks strange and weird right now, but I'll explain all the terms later. So starting with the problem. Given f of x is equal to x to the fourth minus 2x cubed plus 5x squared minus 6, approximate the indicated root, or x-intercept, of the equation correct to 6 digits on the interval 1 to 2. So, to solve this, your first step is you're going to sketch a graph. So in this graph, you can see it looks like a parabola, but the x-intercept isn't a full number or a whole number. It's a hard x-intercept to solve. So we're looking for on the interval 1 to 2, so f of a to f of b, 1 to 2. This is the line, and you're looking for this x-intercept right here. Now, step 2, you have to first check the properties, because Newton's method will not work unless if one of these properties is not met. So we can see from the graph, is it continuous? Well, yes, there's no discontinuities. Is it differentiable? Yes, there are no cusps or vertical asymptotes. Is there a sign change? Well, we can see f of a is lower on is negative, and f of b is positive. Now, the next step, we have to pick a starting point. So we can see from a graph a zero occurs close to x equals 1.1. So we'll use this value as our starting point. Now, step 4, we have to find the derivative. So the derivative of f of x is equal to x to the fourth minus 2x cubed plus 5x squared minus 6 is 4x cubed minus 6x squared plus 10x. Now we're going to need to use our calculator to use iterations to solve this. So you put your y1 as the f of x and y2 as your f prime of x. Now we're going to make a table that looks like this. So n will be the number of trials that you do, x of n will be the x value that you are using, f of xn is the y value for that x, f prime of xn is the first derivative y value of that x, and your iteration will look like this: x of n minus f of x of n over f prime of x of n. So here's what the first trial will look like. We used our starting point as 1. We found that f of x of n is negative 1.1479. F prime of x of n is 9.724. And then we just plug this into our iteration. This gives us 1.21804881. Now our second trial, we'll use this x value for our second trial. That will give us 1.216263. Now, we need to make these two iterations equal to 6 decimal places. So we are off already on the third decimal place. So we do it again. Now we get 1.2175706. So we have the first 3 decimals to the same place, but we need 6. So we do it again, and we get 1.2175632. Now we have 4 decimals to the same place. We do it again, we get 1.2175623. Now we're missing only the last decimal. So our last iteration will give us 1.2175622. Now these two iterations are equal to the 6th decimal place. So we can say that f of x is equal to 0 when x equals 1.217562. This complies with our direction of iterations less than 0.0001. We can approximate that a 0 occurs at x equals 1.217562 for the function f of x is equal to x to the 4th minus 2x cubed plus 5x squared minus 6 on the interval 1 to 2. Thank you for listening.